Okay. Hi, my name is Mark Weisser. I'm the CTO, CIO of WaveGuard Corporation in Denver, Colorado. And this is Architectural Challenges, the Man-Machine Interface for Distributed AI Industrial IoT Systems. What a mouthful. Maybe some definitions of the words or some confusion about the words, but let's give it a go. And that's what the next 13 slides are about. IoT. Everybody's heard it, no doubt. The Internet of Things. No problem. That one's pretty simple. The next one, oh wait, there's another definition of the Internet of Things. Oh, here comes another one that kind of does and says what it's supposed to do. Well, guess what? There are 5 types of Internet of Things. Consumer IoT. You know, the stuff you put on your house, your watch, whatever. Commercial IoT. Well, wait a minute, what? Yeah. Just means bigger IoT systems, really. Industrial IoT. Now, that's a little more involved. It is pretty dynamic. It has to do with the communications between IoT devices, SCADA, and machine something or another systems. I can't remember what it is. Infrastructure IoT. What? Somebody else created another name. And, the military Internet of Things. Battlefield Internet. That probably comes closest to being more dynamic than industrial, but everybody has their own opinion. And as you can see, IoT is like just a big trash can of terms. What's industrial IoT versus regular IoT? Because that's what I'm doing, is it industrial? Scope and scale. That's pretty easy to figure out. I don't really have much more to say that you can't read that. Complexity and precision. Yes, the stuff at home is not anywhere near close to the precision or security of what an industrial IoT is. But more precise, more complex. Connectivity and interoperability. Right, another mouthful of terms. I feel like I'm creating a word salad here, and that's kind of my point. You can read through all this stuff. You can find all these things on the internet. I stole some of them. I apologize to the people I stole it from. I didn't have time to put annotations to this one. I will. Security protocols, the same thing. How is HTTPS good enough? Do I have to have something better? What level of encryption do I need? All kinds of things like that. And the management of it. Programmability. This is the biggest difference, really, between IoT stuff and industrial IoT stuff. There is a very narrow, on your home, commercial, consumer stuff, very narrow set of parameters you can put in. On industrial IoT stuff, that becomes much larger. But I'm not really a fan of the word salad. AI, same thing. Another word salad. What is AI? They break it down into 5 things. 1, 2, 3, 4, 5. As it grows, this terminology just gets ridiculous. At the bottom of the page is expert systems. We'll talk about those in a minute. And computer vision. Speech recognition, we're not there yet. The difference between AI and machine learning. Machine learning, a subset of AI. Yes, the rule sets of AI. All AI is based on rule sets. Don't care how old it is, how new it is, it's all based on rule sets. How we get to those rule sets defines the other parts of that AI that you saw on the previous slide. Essentially, all machine learning is AI, but not all AI uses machine learning techniques. Rules-based systems, expert systems. But there's a blur. And so when I used to say AI, meaning machine learning and expert systems, it's really, we've moved beyond that. So we really need to say machine learning, hybrid systems, and expert systems. After this, man-machine interface. Oh, that's an outdated term, by the way. It's HMI now. What is this garbage? Internet, we've got forms, we've got all kinds of interfaces in the world. Your damn phone is an interface. Ancient terms, the point being is where the guy's finger goes. Whether it's a control panel in the old days, which is called a push button replacer, or a data handler, or an overseer. All the same stuff, but they're all hybrids now. Architecture, great subject. Lots of stuff to talk about. Where, when, how, software architecture, systems architecture. You can go on for friggin' ever. The complexity of architecture is interesting. I haven't tried this, so I'm going to go from here. No, it's not going to work. Well, you rotten thing there. Let me see if I can get to the screen. If it'll work. I wanted to go here. Yeah, there we go. Of course. Just as anything goes. Let's try this again. No, it's not even going to be nice and user-friendly, is it? All right. Well, there it goes. If you look at Wikipedia, which is not the best source of things for definitions of architecture, it gets ridiculously long with various different frameworks and all of that kind of stuff. And I can't show you, so I'm not going to. Go yourself and type it in, and you'll find it. Martin Fowler is probably the leading person on architecture in the public. But this is not his drawing. Even he has a hard time with defining what architecture is. I get it. It changes very quickly. Everybody has their own opinion. Well, so do I. Let me see if I can get this thing to cooperate now. Nope. Come over here. You run the thing. There we go. Hopefully it'll work now. Oh. Now I'm getting click happy. My goals and design decisions. Simplicity, supportability, maintainability, security. Should put security first, but if it's not simple, it's hard to secure, so I put it down the road. Flexibility is an easy to make changes. Shardability for databases. A lot of databases aren't designed for shardability. Most of them. Look at WordPress's database if you don't believe me. Modularity, meaning I can take this piece of code from the client and put it in the administrator, and it does the same thing. Reuse of code. Like, don't write so much of it. Put it in a class, import the class if you have to, and go. And affordability. Hey, what's that? Everybody just throws money at it until the guy's overlords say, hey, don't do that. Now, this isn't that kind of guy. Look at affordability too. The last part, which is the hardest part, is to look outside the box or be forward-looking when you're looking at design. Like what things are going to change no matter what you do and be prepared for. What about multilingual use? Multinational use. A long-term goal is to make the human-facing elements, is to create a front-end client to the API model where the generated client code base can be used to create a progressive web application, Android app, and an iOS app using something like Quasar Framework or a single code base equivalent to make your life easier. You don't have to rewrite everything. Transpile it, as they say. Not a fan of that term, but basically recompile it is the older term. My thinking about architecture, one, it's about data flow. That's all, period. Optimizing data flow. Kind of think about it like the OSI TCP/IP model. I haven't really drawn it up as to what my actual thinking is. But I'll get there. Because it's something I'm a little bit passionate about, especially after this project. And tools. What are the tools I'm going to use? Because that defines the architecture also. So this is the company I work for, Waveguard Corporation. Okay, so we're going to just cruise by because I'm not going to mess with this again. I didn't have time to practice, so. That's who I work for. Google it. You'll see what our system stuff does. We have a patent. And I would click on it, but I'm not going to trust it now. This is the equipment part of the equipment that's patented. This is right in my lab at the house. You can look at the patent. They look exactly the same. The switches and stuff hanging out the side of the edges of it are to simulate the sensors that are out in the field or on a pump in the container, etc. That's our brains baby. That's what I talk to in my system. I've had influence, but I'm in the design of the code that's on it, but not the electronics. I can and I will have, but not this part of it, not the patented part of it. What are the challenges? Sorting list. Apparently I can't spell sorting, or the stupid thing didn't like it. Proceeding work. When I first went to work for these guys, I looked at the code, nice clean code, except they set the value of the variables to the optimum at the very beginning of the code. Instead of setting them to just empty space, they set them to a fixed value that the system works. Well, you know that told the people that were trying to make the controller work the wrong answers. Of course it did. That's just the nature of why you don't do that stuff. So the first thing I did was rewrite the code. And I needed to rewrite it so it was quick. And I'll explain why a little further. Hardware-induced things. There's a bunch of hardware-induced things. Can't go too deep into it, but that's the way it is. But our system, AI, its life cycle, well, it goes on a house. It's not a car that has the typical service life. It goes on a house. It's going to last 30 to 100 years, and we have to maintain it. Think about the changes that you have to deal with in your architecture and your structure when you build it for something that's got to support for that long. NASA dudes do it. They send a satellite, because those are expert systems. They send a satellite out. How many years has the satellite been? I forget the one that's the furthest away, but it's been gone a long time. Over 1 million light years. The location of the AI. What do you mean? Well, it sits near a house. You got Wi-Fi to talk to it. You got a control panel that for the simple emergency things like, oh, damn it, there's a fire and I'm scared out of my mind and I want to hit the button. You can do that. Oh, wait, I want to have a campfire in my yard. You can hit the button and turn its eyes off. so it doesn't pick up the campfire as a fire. To the further extreme, because of the sensitivity of the sensors we use and the quality of the sensors we use, they have a bit longer range than most. Well, in places that have fires, they have a winter time. Well, they have lots of burn piles. So now we have to adjust for that. So it's a very moving target as to what the system's supposed to be. It's also in residence. It's in a business. It's in wherever you want to put it. Golf course, vineyard. They don't know about this stuff. They don't understand any of this stuff. So you have to make it easy for them to understand and use. But if it's AI, why do we need to have something for them to use? Well, because people are people and they like to have control and they like their app. And that's the way it is. And the knowledge level has to be such that they can use the system and have it make sense for them. My knowledge level, hey, people just don't do this stuff. I mean, to create a whole entire market, a system to do it, actually have it be an expert system, and they want to talk to them. It's been a little bit of a learning experience, but nothing tragic. But all the different transitions and the transitions that have to be managed along the way when my boss is learning and I'm learning and we're both coming together create some interesting issues. But it's really cool. So, version 1. Design decisions for a system where remote devices report every 15 seconds. Hopefully. No, they do. The client device refreshes every 60 seconds. And the status reporting device, which we monitor to see what our systems are doing, every 7 seconds, because all these things report every 15 seconds. So how many changes do you want to be able to see? How important are they? Do we need to know that we've lost connectivity in half an hour with the internet, or 6 days, or whatever? Those are all considerations in the design of the system. At one point it was 6 hours that we wanted to know. Okay. Now we're at about an hour just because we want to see what's happening more closely. But it can be set whatever I want it to be set at, or my boss wants. He makes those calls. This is what it looks like. This is the architecture I came up with for the initial version when I first took over the code. Your device. Now, and this is actually the code we're running right now. 45 of these out in the field with the version of firmware in them that report like this. Runs to a server, collects it, writes to a database, and we have an admin page. That's it. There's nothing fancy there, but I wrote the code so that when we go a little further, I'm prepared for a little further. It doesn't look that complicated unless you add the fact of all the people that are involved and all the houses that are being protected and all that stuff. It gets a little complicated. Version 1 reporting system, variable count, 5. That's it. Average value, 2. It's binary. That's it. Not a big deal. But, got to be quick. Version 2, variable count, 11. average count 5.5. There are maybe 2 binary ones. And you'll find that using 0 as part of your reporting is bad practice. Never use 0. Everything we have that's binary is a 1 or a 2. Now, version 1, 0, and 1. Yikes. Then version 2 adds input data from the client. 1 variable, 39 values that it can be. Double yikes. Because they can come in from 45 different people or multiples of that, depending on how many people you allow in the system at each place. Kids. Yeah, we have it planned out so that kids can have access to certain things, like turning the suspend on after they start a bonfire and forget, which will stop the system in its tracks. But that's up to the parent. It's a reduced set of instructions that they're allowed to have. So that made it this system. A little bit busier. A lot more permissions, a lot more authentication, a lot more places to get the wrong information coming from smartasses out in the world. We have a thing for that. It's called, you scan every piece of data. If it doesn't fit in your system, don't let it by. Just kill the process. Your server will take care of, if it sees that enough times, if your server's configured properly, it will blacklist it. And that's the end of it. Version 3. Yes, there is a version 3. And I'm partially working on that too. Version 3 has some interesting features to it that my boss didn't tell me he thought about. And it was customer driven and experience driven from the last few years. But I don't get too involved with the day-to-day operation. So it was a little bit of a surprise, but it didn't impact me as a developer yet. It may, and that might be a pump. I don't know what I'm going to do with it, because it's a whole different gig, and I can't tell you that. That is pretty much my challenges for this system.
I have 2 questions for you.
Sure.
The first one, so these devices report in every 15 seconds. If it happens to get to the point where most of them are at the same 15-second boundary, is the system designed with enough capacity to handle that?
Well, I was a pretty smart fellow on this one. If you're writing to a database, correct, and you put them all in the same table, guess what happens? Crash and burn. So each device has its own table. Period. So no collisions. Capacity-wise, the shardability of the database, it's designed absolutely perfect for shardability. I cut it in half. I can cut it in one for every table if I need to. So basically all I have to add is throughput capacity. I also designed it so that when you put when the table is already pre-created, when you add a new device, it just copies the original table. So you end up not having to worry about anything else. And everything's numeric for the table. So I can go through and look at any numeric table with a single query and build this. And I can show you one. I can show you this part. What was your second question?
Redundancy.
What about redundancy? What's redundant? Let's see.
What is it?
So the way the system's set up currently, because we're not housing any critical data besides your typical backups and all those kinds of things, if I need to ferret out to another system, I can. All I have to do is turn it on. That's the one good thing about cloud computing, is that you can have one sitting there dead, and we haven't had a report for X number of whatevers, because it's on a screen somewhere that people can see what's going on. Oh, hey, there's no critical data being reported as far as functionality goes, because the device is AI. It's all totally encapsulated. Ah, crap, we don't have any recording. Big deal. Okay, turn on the other one, figure out what's wrong with this one, turn it back off. And they'll all point to that same URL, so I don't have to worry about it.
Well, let me hit you with a question.
Sure.
Different area. I might know the answer to this, but I'm curious your experiences about not using the value 0 in the reporting data. Yeah, to always begin with 1 or greater.
Yes, absolutely. Null suck. 0 sucks. False sucks. True. True sucks. The original system has 5 variables, 0 and 1. Well, okay, it's really easy if that's all you're reporting. If you're reporting other things, dealing with the null, you have to check if it's set or not. So it takes one step out of the process. It's either set or it isn't. Well, is it empty set, or is it, a bunch of different things go into that. When you're posting stuff, don't ever post a 0. Because invariably, since there are 2 of us developing in 2 different frameworks, because he's developing it in machine language, and I'm developing it which is, in his case, is using hex for everything. And I'm developing in this, and everything when you post it to another device turns into a character. What is 0? Is it 0 is 0? Is 0 null? Whatever. You have to be able to do that. So don't use zeros, because then you can convert your post variable coming in to an integer, which means you can store only an integer, which means you store less space in your table. Zeros and nulls are not good storage values, but unavoidable. So don't store 0, store null. Sure.
So, what was the original idea for the system? How did they come up with? Is it something that they saw someone else doing? It's something original?
No, it was
from them.
Randy. Randy had the idea. I'd show you. Can I use your laptop?
Yeah.
I feel like I'm hamstrung here. I just want to make sure I don't lose anything. So hit enter. Go, you piece of crap. Okay. Except, of course, it's always the wrong side of the screen.
Mm-hmm.
Especially when you're dyslexic. Really terrible. Okay. So this is the product of that controller. This is a very large house in California. And we have had success in keeping houses right in the middle of a fire.
So you have had success.
Oh yeah, we're the only proven system.
So there was like a fire ranging all around.
And the houses on either side burned down. His didn't. Yeah.
Was that in California, out of curiosity?
Yes.
So how do you, I'm sorry, but how do you price this stuff? You go by the size of the property? You go by like a...
You go by what the customer wants to protect. So we can protect, this is kind of the part of the system that runs. So a property has its characteristics, whether it's a vineyard or whatever.
Mm-hmm.
I think our current biggest system has 7 master systems and 7 master systems and 1 with a satellite, but 8 separate cabinets on it, protecting 10 different structures coming up. We're working on doing a bigger property, hopefully, the size of basically 6 square miles. However, we won't protect all of the 6 square miles, but we will be protecting the golf course.
You protect even the golf course.
Yeah.
So you have to have like a huge tank, and you give the person, I can protect your property for 5 hours or 10 hours.
Well, the way the system works is it's designed so that there are multiple, we provide enough water to spray the system, and put retardant out, and then we can refresh the retardant. And I can't get into the technical terms of how that works, but it's for quite a while, quite a period of time. We even have a low draw to make sure we get in the cycle. I can't remember what the name is here in a second. That basically energy conserve. You have an energy conserve part of the cycle that will turn stuff off, but still monitor if it needs to run.
Okay.
We size everything to what the demands of the area are of the property.
And whoever Randy is, he came up with...
Randy came up with the idea. Let me see. Here's Randy. This is Randy talking about one of our successes.
There's going to be no sound because it didn't connect the sound to the computer.
I didn't connect the sound to the computer? Oh. You didn't give me the sound to connect to
And
the
it's only
computer.
going to come out on the computer, not on...
Of course it is.
Crank that tab up.
I don't see the hole. Oh, because it's on the end. Never mind. I got it. Blind in one eye, can't see out of the other. Why did it go dark?
Oh, here we go. It's back.
I gotta do that.
Oh.
Sorry, guys. Give it a second to warm up. Volume doesn't look like you have a lock on, so.
Oh, yeah.
That's loud.
And in a few hours, we will get a snapshot of Arizona's wildfire outlook for this season. Wildfires can change lives right in an instant, whether you lose your home or you just witness one of those tragedies. It is why Randy Lang created WaveGuard. Look at this thing. Lang and his family witnessed a destructive fire in Colorado a few years ago as they were helping people to evacuate.
The very
a light bulb
first
went
system
off.
we built.
Someone had said, it's too bad we can't put a sprinkler system on the roof, and I got to thinking about it, and I said, well, we can. We just have to control it differently.
That sprinkler system can detect flames about 350 feet away,
that's my
and it
boss's
sprays the
family
areas
cat.
around the home up to 40 feet with water and retardant. Now, the pumps are made in Safford. WaveGuard is now trying to work with the National Park Service to protect visitor centers. Talks in Estes Park, Colorado are already in the early stages, and that system ranges in price from $5,000 and above. WaveGuard, though, they say they're working to try to bring that cost down, working with insurance companies, maybe give homeowners incentives. Lang says the system is great for Arizona because the system also has a roof cooling setting for those hot summer days.
Yes, we do have roof cooling, but when you go to put it on, you have to go to the control panel, the button pushing system to turn the roof cooler.
Okay, so is he an engineer? How did he come up with
He's a sales guy for a large, what do you call it?
Irrigation or
Irrigation and grass cutting irrigation company.
Yeah.
I don't know his relationship to the company other than Ken, who used to run the company, who also owns part of the patent, and Michael, my boss. Michael's the guy who figured out how to get the system to work. He's he's an electronics guy, but he worked in the irrigation industry also. Let's see.
So, okay, who wrote the, because you said that when you came in, the system was already out.
The company that we buy the controller from wrote the code.
So they're the ones, so they picked everything from what kind of hardware to the software.
No. We buy a microcontroller from them that drives the system, that bot thing I showed you. We buy the microcontroller from them. Okay? Now, Michael's modified the board that it lives on by huge amounts. But the controller itself, we buy from them. They wrote the original software that I fixed because they wrote it wrong for the system, the recording system. Go ahead, just talk, man.
Out of curiosity, how did they allow you to fix it? Was it open source, or they claimed no?
It was written, the reporting side was written in PHP original. So, and since it wasn't hard-coded, give me the server, I'll deal with it.
Okay, so the board, they had the code that you could refresh?
No, you're confusing things.
I say
you're
hundreds to
confusing
mutual. Liberty, liberty, lib.
the controller and the reporting system. Okay? The network card has on the controlling system has a PHP server on it that runs the output string out to the reporting server also.
So there is a board, and that is on the client, there is a web server. And then that web server talks to your server.
Right.
Okay.
So that gets plugged into a Wi-Fi connection or a hardwire connection and gets sent out across the customer's internet to our connection. That's why we have to keep track of connectivity, because if we don't see it, that means they either change their service provider, something happened to the Wi-Fi, etc. And since we're going to depend on the Wi-Fi for the client in their hand to work, we have to monitor it.
Okay, so a property in the middle of nowhere, you cannot service it?
Sure. That's what they make cellular and satellite for.
Oh, okay. Okay, let's say that the fire is raging.
Yep.
And I cannot talk to the server. So that's where the AI
It doesn't
comes
matter. It doesn't matter because the server's an extra piece that's for convenience.
in. Oh.
Okay. It's when I say AI, it's AI. It's an expert system. It just sits there and does its thing. It doesn't care. You don't need a button. You don't need to push a button. You don't need to touch anything. The problem is that everybody wants to touch, wants to have
Wednesday, October 23rd, 2019 at 9:24 p.m. What is now known as the Kincaid fires in Sonoma County began. Unconfirmed reports of the origin of the fire. The fires moved quickly through Sonoma County, including communities of Gaysirville, Healdsburg, and Windsor. This was to be the largest fire in the 2019 California wildfire season. The largest wildfire in the history of Sonoma County. The wildfire was devouring everything in its path, moving quickly with winds as its driving force. Thursday, October 24th. Monitoring at WaveGuard headquarters,
No, he doesn't work for
fires
us.
moving in the direct path of a home with a WaveGuard exterior wildfire defense system installed. A home in Healdsburg. All faults verified the system was ready to go. As the fire raged on, firefighters were doing everything they could to fight the fires. Sonoma County experienced record-breaking winds up to 102 miles per hour, with consistent intermittent wind gusts that averaged 70 to 80 miles per hour. Saturday, October 26th, the homeowners received the orders to evacuate. Upon evacuation, they ran the roof cool function one last time, soaking down the home and a 30 to 40 foot perimeter. The smoke and fires were moving in quickly, and it was time to go. They looked back one last time. After their evacuation, PG&E cut all power to the area. Without the communication of their internet connection, WaveGuard headquarters had to switch over to CAL FIRE Maps, watching the movement of the Kincaid fires in their area. WaveGuard could see the fire's footprint had surrounded the home. With the power and the water out from the grid, how would the home be protected? The WaveGuard exterior wildfire defense system is fully autonomous, with its own power and water source. No human intervention needed. Tuesday, October 29th at 7:30 p.m., WaveGuard received a phone call from the homeowners stating the system had ran as promised and their home had been saved. The devastation of fire was all around them. Their home remained unscathed. 174 homes were destroyed, 35 damaged. The WaveGuard patented exterior wildfire defense system protected and defended their home and precious memories from dangerous wildfires.
Now you guys saw what the house looked like before and after the fire. So, you can see. Does work.
So what type of power system is in that thing, kind of sort of?
We have 3 power sources we can use. We can use solar. We typically use city power, but we have a ginormous battery backup system. 48 volt system inside and a 24 volt system inside. And soon to be a 12 volt system. Small for the 12 volt system. But in the last propaganda,
Malibu is a beautiful and inspiring place to live. It also supports raging wildfires and powerful rainstorms.
now the guy
My
that
family
built
moved
these
here in
videos, these last
1997,
two,
and our home burned to the ground in the 2018
has been my business partner
Malibu
for about
wildfire.
20 years.
Now the burned hills are the source of dangerous mud and debris flows caused by the wildfire.
Your home does not have to be the victim of wildfires. By installing an autonomous WaveGuard system, your home will be protected 24/7, even when you're away.
The WaveGuard system has storage tanks filled with
That's
the
my
water
box.
supply. The pump is a 48 volt battery operated pump, so if the grid goes down, we're totally self-contained. This
Oh, no,
particular
that's 10.
system has
I
enough
forgot.
water to operate
It
consistently
sounds very much
for 1.5 hours. Fire's going to pass by in about 20 minutes, so the flame detectors are going to pick flame up at about a foot high at 300 foot. It's going to activate pumps for 20 minutes. If the flame and the fire goes around it, it goes into the safety mode. Once it detects no more threats of a flame, then it is shut down.
One of the things I like about the WaveGuard system is that it is off the grid. It's autonomous. We can lose water pressure from the city, we can lose power from the city, and it'll still continue to operate. And it's even got a system where it'll run for about 5 minutes, go off for 10, run for 5, go off for 10, in case our embers still coming from a fire that's already passed.
In order to allow the system to be completely autonomous for an extended period of time, we put solar panels on top of our cabinet, which provide an amount of electricity
the
that keeps
internet
the batteries
connections there.
recharged
Little hubs that are
for
sticking
an
up.
extended amount of
That's my
time.
boss.
The batteries themselves, without recharging, are good for over 2 weeks' time. With the solar panels, we can run this thing indefinitely. If the homeowners were evacuated and power was cut and the utility waters were shut off, this system would continue to operate and function normally for however long they were evacuated.
Our motivation in installing the waveguard system was the memory of 40 years ago when the house caught on fire. There was a brush fire in the area. So we just feel like it's a real serious threat, and we want to do everything we can to protect our house.
We have a storage tank of fire retardant. Once it goes into full alarm, it will be injecting fire retardant that's being applied with the water. The fire retardant that we use is biodegradable. It doesn't harm plant materials, it doesn't harm human beings, it doesn't harm animals. It can dry and it be reactivated by water again within a 2-week period.
Fire retardant is capable of being used in oil or petroleum fires, as well as hydrocarbon fires like we experience here in California.
As a homeowner in Malibu, I thought I had done everything possible to protect my home from wildfires. I had concrete siding on the sides of the house. I had defensible space over 200 feet in every direction of my house. I removed any shrubs and trees that were living next to my house, and I had 8 sheep that ate all of the brush and debris around the hillside on my home. And my home still burned to the ground because I did not have an active water defense system for my home. And because of that, when I rebuild, we are definitely going to have a waveguard system installed in our house.
Did some research, talked to a lot of people, phone calls, emails, and decided that waveguard was the most comprehensive system. Very helpful, very informative, very proactive. I'm hoping that a lot of our neighbors buy this system because we want to have community immunity. We want to have everybody have this system because it's not about if this fire comes, it's when it comes.
Peace of mind is guaranteed with the waveguard system. Make waveguard your partner in fighting wildfires. For more information, visit waveguardco.com or call 800-980-4401.
Okay? So, you can understand that the kind of coding that goes into both on his end and on my end to make this thing work.
Mission critical.
Huh?
Mission critical.
Yeah.
Malibu
Sorry.
is a beautiful and inspiring place to live.
So how big are these tanks?
Depends on the size of the house. Depends on the area you want to protect. We size them. We size them so that, like they said, 2 weeks it'll run. We have in the controller. It knows, hey, I got to chill out and wait. So if I see another ember 2 weeks from now and nobody's here, I can fire. And wet down the biodegradable target, and they're back to ready to go.